Hi, this is Michelle Cullen with Astronomy 103A, presenting the 4 stages of planetary development. I'd like you to be familiar with the stages that the terrestrial planets undergo and the forces that shape these planets to become what we see today. Last week we looked at the formation of the solar system, and now we will pick up where this left off. 4.6 billion years ago, the newly formed inner planets are made up of rocks and metals, and they're much denser than their icy outer planets. Remember, the temperatures of the inner solar system were too warm for the lighter hydrogen compounds to condense, so the inner terrestrial planets that we're looking at today are made up of mostly a rocky composition. Let's look at the planet shaping processes. The first one is differentiation. The second one is cratering. The third, flooding. And finally, slow surface evolution. So these 4 processes are what I'm going to talk about and explain to you in today's lecture, mini lecture. The first stage of development is a process of differentiation. This is a sorting of the material in the planet's interior. This sorting ended up with the planet having the type of interior we see today. We have the solid core, the molten outer core, the rocky melty mantle, and the extremely thin crust. Materials sorted out and differentiated because the early planets were molten, and heavier elements could sink into the middle, while the lighter elements floated up to form the crust of the continents. So the planets had several reasons why they were so hot and became easily differentiated into their components. One of the sources of heat is the original heat left over from the violent accretion process, or the formation of the planets. And another heat source is the heat of radioactive decay. Of course, the weight of the planet makes the interior very hot just from the force of compression as well. Now that our planet is organized inside, let's look at the process that occurs on the surface, cratering. When leftover planet-forming material, now think meteorites, asteroids, and comets, when they hit the cooled down crust, an impact crater was left on the surface. Today we don't have that many comets or asteroids hitting the Earth, and one reason is that Jupiter's massive gravity tends to get them. The other is that we have our atmosphere that helps protect us and burn up many of the smaller meteorites. But in the early chaos of the solar system, there were abundant collisions with icy bodies that likely deposited much of the Earth's water, forming our oceans. The airless Mercury and Moon leave a permanent record of the process of cratering, as the ancient impact craters on Earth have been covered up or destroyed by our planet-shaping processes, that of flooding and slow surface evolution. The third stage of planetary development is flooding. Early flooding on new planets was by this molten rock, known as basalt. The warm interiors of the planets released their molten basalt to flow down and cover low basins. The dark maria on the surface of the Moon is an example of the flooding process. The smaller planets in the Moon don't have active flooding by basalt anymore because they're geologically dead, but Earth and Venus are still active and do have active volcanoes that flood and shape the planet itself. On Earth and on early Mars, another powerful type of planet-shaping flooding was that of water. Rivers and rain carve canyons and erode mountains. The fourth stage of planetary development is slow surface evolution that happens on planets with active geology and weather. On Earth, plate tectonics continues to push up new mountains, while the surface processes of weather erodes the surface. Moving air and water help to shape the surface of planet Earth, carving canyons and eroding coastlines. Wind in the atmosphere of Mars shapes the planet's surface today. All 4 of the processes that shape planets take energy, but it's interesting to note that where the energy comes from to shape our planet, when we look at plate tectonics, we can think about mountains being built and that energy comes from within the Earth. Now, the heat that is produced inside the Earth is actually enormous. This radioactive decay and the interior heat left over is it's powerful, but it turns out that it's actually 5,000 times less powerful than what the Earth receives from the sun. So the sun is a much bigger source of power. It drives the weather and ultimately causes erosion. So it's ironic that when the Earth's heat makes the mountains, the sun's energy tears them down again, bit by bit. Well, I hope you have a better understanding of the four processes of planetary development, and now you understand differentiation, cratering, flooding, and slow surface development.